So good day. My project is a succulent classification mobile app. So this system basically takes in succulent images and it outputs the name of that succulent, its price, and some care tips. The game plan that I have followed has three main stages. The first one is dataset gathering. Since I could not find any images online, I gathered my own data by myself. So I went to the greenhouse and took a video, 30-second video of each succulent that I want to include in my data set. And I rendered those videos into images. Since there are like 25 frames per second, I have rendered the videos and each video would produce like 700 images. So each class, I have 700 images. So the total data that I have is more than 6,000 images. The second main step after gathering the data is training the data. I used Google Colab because it's easier and friendlier than Jupyter. And the best part about Google Colab is that it offers a free GPU. Since my GPU is not that high performing, I need a GPU so that the training will be faster. It's more efficient. Okay. I think their GPU is like Tesla, NVIDIA Tesla K30. Okay, so the other frameworks and libraries that I have used a TF Lite model maker since I have utilized transfer learning, which I will discuss later, and the frameworks TensorFlow and Keras, of course, Matplotlib for visualization, NumPy for uh, processing arrays. And the third main step is the integration of model in the mobile app. So I have used Android Studio, and for the back end, I used Kotlin. And for the database, I use Firebase Firestore, to store the prices. So whenever there is a detection, an information will be fetched from Firestore. So before we go to the walkthrough, I would like to discuss a little bit of how the data was trained. So the first step is to, of course, import the images. So I imported it from Google Drive. After that, the, the images were compressed for efficiency. And then the data set was split 80% trained data and the 20% test data. And as you can see, there are 6,440 images in our dataset with 9 classes or 9 succulents. So here is a plotted images. And this one is the line or the code that is responsible for training the dataset. So the .create method is from the TF-Lite model maker, and we can pass some parameters here, such as the epochs, the train data, and even the pre-trained model that you would want to use. So I used the default, which is the efficient light model. And then after that, the accuracy was evaluated, and it resulted to a 100%, which is not really that accurate because maybe for the test data, since as I said earlier, the way that I have gathered the data is through videos. And when you render that into images, there are instances that images are like the same with each other. So there is a high bias in our data sets. So gathering data through video is not recommended. However, when I tried it in the real greenhouse or real application, it actually performed well, but not 100%. There are still some errors. It's just when your dataset is biased, the evaluation might be inaccurate. So here is a sample plotted result. So it said there here that if the predicted labels are correct, it's going to be colored black, and if it's not, it's going to be colored red. And as we can see here, we cannot see it colored red. So I assume the 100 images, they are labeled correctly. And then the last step is to export the data into a TF-Lite model so that we could use it in our Android Studio. So now I would like to show the walkthrough. Here is our application. So as we can see here, so here is the TF-Lite model. So that's why we have to export it first to be used. So here is our simple application. We have two buttons here. We could take image directly or load the image from the files. First, I would like to show loading of image. And we can see here, we have here black prints, panda ears, po, cuts po, and then I would like to test cuts po first. As you can see, there's the name, the cuts po, the price, and some care tips. Let's try another one. Black prints. So there you go. It has some results. I also installed it in my Android phone and then went to the greenhouse and tried it. So here is the video. This one is pink champagne. Close anyway. Next one is panda ears. And then we have that's else. Wrong. This one is wrong. It is not black prints. Yes, this is black prints. What else? Oh, crystal red. This one is Hercules. Yeah, this one is Hercules. Sino pa kabila? Itsura na po. Okay, so since we are done after the walkthrough, as you can see, the system is doing well. However, there are some instances that the results were wrong, but maybe 90% of the time it was correct. Well, maybe because also it's where I got the data, or it's where I took videos from. So the question, what new concept or idea have you learned during the project making? So I think I have mentioned this earlier. It's the concept of transfer learning, which basically means that it takes a model trained on a large data set and transfer its knowledge to a smaller data set. So basically, it makes learning more efficient, faster with a few data set. It doesn't require a lot of data set because there are pre-trained models based from large CNN architectures. So the knowledge that they are passing are basically frozen weights from the previous learning. So yeah, it makes things easier. And according to one article that I have read, if there are 15,000 images in your data set, you should be training your data set from scratch. But if 15,000 images or less, you should be using transfer learning because that's the most practical way to do. And before using transfer learning, I tried from scratch, and it took like, I stopped it on the 4th hour because I think it's not gonna be finished. So when I search for a more efficient method to use for learning or for training, I have found TF Lite Model Maker, which utilizes transfer learning, and yeah, it made the training faster and with a higher accuracy actually. So yeah, that's for the transfer learning. And now, how I view machine learning. I view machine learning as the future. Actually, I think machine learning is one of the most interesting topics in the whole CPE course because I find it very relevant in the present and in the future. I believe it's going to be very in demand in the future. It's very revolutionary. So that's what I say. I think machine learning is the future. So that's all for my project. Thank you.